This is my AND gate design, simple AND gate design. Module my AND in 0, in 1 and out is my port list. Where in 0 and in 1 are single bit input ports, out is a single bit output port. There is a reg called out because I'm going to assign the output inside the always block. Always at in 0 or in 1, this is my sensitivity list. Begin the always block. Out gets in 0 and in 1. So this will implement the AND gate for me for this design. Out will get that and the always block end module. This is my test bench. For the test bench, first thing you have to declare is a time scale. The time scale is for simulation purpose. There are two values. First value is for the simulation. What is the time scale of the simulation? So 1 nanosecond and increments of 1 nanosecond. And the second part is called precision. Precision means I can zoom in my simulation up to this level, not beyond this level. That's called precision. Module my and test. So every time the test bench will have empty input output ports because the test bench itself will be applying inputs to the design and monitoring the outputs coming back from the design. So there are no additional input output ports required at the test bench level. So test benches are normally empty port list. And then this is my instance of the AND gate that I'm instantiating and mapping this to the local signals. So local signals in the test benches, any inputs going to the design will be registers. In this case, N1 and N2. And any output coming back from the design will be mapped to a wire. Why? Because the registers, the inputs, I will have to change. I will have to apply the stimulus or I will have to apply the inputs to the design. So I'll have to change those inputs and then based on the changes in input and the design logic, different outputs will be generated. So I will monitor at the test bench level what are the inputs applied and for those inputs what are the outputs generated by the design. Then I will summarize or I'll conclude that whether there is correct result or not correct result. If it is not correct, I'll have to make the corrections to make it correct. So these are my inputs which are going to the local registers here at a test bench level. Initial block, begin the initial block. So I'm going to change the input values in the test bench. So in one is 1, 1. So this is AND gate, two input AND gate. So I'll apply various a combination of two inputs. First is 1, 1. Both inputs are 1. Then hash 5 means hash 5 into 1 nanosecond. This is my time scale. So after 5 nanoseconds, in 2 will be 0, in 1 will remain 1. After another 5 nanoseconds, in 1 will go to 0, in 2 will go to 1. Another 5 nanosecond later and both inputs go to 0. So I apply various combination of these two inputs here. In the initial block and end module. This is my test bench. Do you understand this test bench, how it works? Any questions on the test bench aspect?
Yeah, I understand. So one question is for the AND gate, it's only 4 combinations, right?
Yes.
0, 0, 1, 0. But you are trying multiple combinations over here.
Yeah, you
So
can
in this,
remove the other things if you want. So 1 0 1 1 1 1 0. No, the reason I tried it out was now see this here. Now here both are 0, then both will be 1, then 1 0. So I'm just changing different combinations. That's it.
Okay.
In the first 4 combinations also you can make out whether the design works correctly or not. I think did I copy them multiple times? Yeah, I think I copied them. I'll just remove them. That's just a two input AND gate, so 4 combination is good enough. Okay.
Okay.
1 1 1 0 0 1 0 0. So how do I now? I want to simulate this design. So I go to Xilinx IC. This is Xilinx IC for 14.2, but you can use something else. 14.7 is the maximum available on the web. I'll create a new project. So we just So this is the path where my logic is, and I'll call it project and 6 because I have created multiple projects there. So give it a name which is suitable, and under create in that directory where your AND gate source files are there. Then the rest of the things, so family, you can choose one of the families. So this is one of the boards I have, Spartan 6 boards. I've selected that Spartan 6 and or the device number, but you can select any board details here. Language preferred is Verilog because my design is in Verilog language. Rest of the stuff can remain default, whatever. Say OK. So project is created. I want to add the source code to the project. So project add source. One level above. We are currently into the project and 6. So this is the implementation directory. One level above is my source code. So I selected the design and the test bench. The design association is all simulation and implementation, but the test bench is only used for simulation. So association for the test bench is simulation. Say OK. Now if you see here, there are two tabs, implementation and simulation. I'm going to go to simulation first. Under simulation, you'll find a test bench. If I expand this, under the test bench, this is my design which I have instantiated. So I select the test bench, which is the top level of the design of the test bench. I expand this and say simulate behavioral model. Okay, so these are the test bench related signals. So I select, these are selected, I can right click this name, long name. If I do that, all these signals are under test bench. If I want to add design related signals, in the left hand side here, bottom screen, instance and processes. This is my test bench. I expand this. This is my design instance and one. Why and one? Because in my test bench I am calling the instance label and one. Okay, of the design. So to add signals related to this design, I select this, right click, add to wave window. The signals are added. I will again, these are selected, so I will again right click them, name, long. If you see under test bench, under the design instance, these are the signal in 0, in 1, and out. So these three are design related signals. The top three are test bench related signals. Okay. Now since I added this after simulation, there is no waveform error. I need to relaunch my simulation. I will not save any changes right now. I'll just relaunch my simulation. So now I can see, I can do a zoom all. You see, this is where all the inputs are changing. So I'll zoom in this area. Let's see whether, now this is my timing diagram. Let's see whether it is correct or not. Initially in 1 and in 2 both were 1. So output was 1. After 5 nanosecond, in 2 went to 0, in 1 remained 1. Since one of the inputs went to 0, output went to 0. Another 5 nanoseconds, in 2 went to 1, in 1 went to 0. Again, one of the input is 0, other input is high. Output stayed 0. After this point, both inputs are 0. So output stayed 0. So if you want, you can make another change here after this. Let's make both inputs high. Finally. So let's see if the output again goes high here. So I made the changes, save this. If I say relaunch, it will recompile both the design and the test bench and resimulate it. So let me do that. Okay, so if I zoom into this area, yeah, see now here in 1 and in 2 went high again. At that point, out went high again. Okay, so when both inputs are 1, output is 1. When one of the input is 0, output is 0. So that seems to, or both inputs are 0, also output is 0. So that's how a AND gate will work. So this timing diagram seems to be okay. I can say the functionality is correct for my design. So the my design is functionally verified. We can say that my design is functionally verified. Later on, I can go to the synthesis and the backend process. Okay. Hello.
Okay.
Yeah.
Yeah.
So this is my source code, the design and the test bench. I added the design and the test bench. I created a project and to which I added the design and the test bench. Test bench association is simulation only. Design is both simulation and implementation. So I need to go into simulation tab where I will find my test bench. Under the test bench, my design will be instantiated. So test bench is top level. I select that, simulate and click simulate, or double click the simulate behavioral model. It will, if there are any errors in the Verilog code, it will show you here. So you have to resolve those errors first, any syntax errors. And then it will open up this simulation window where you can add the test bench related signals and also add the design related signals. How do I add a design related signals? Under the instances part, under the test bench, if you expand this, you'll find a design instance. You can select that, right click and say add to wave window. And all the signals here, you can say control A, which means control all, select all the signals. Right click that, name, long name. That means it will show you the long format, name in long format, signal name in long format. So test bench and then the signal name, test bench signal name, test bench signal name. So first three signals are for the test bench only. Next three signal, test bench, the design instance and signal name. Same for the next two. So the next three signals are the design related signals. So you can find out, I mean, if once you do the simulation, you can find out if in this case, this was a simple design, so it worked. Sometimes your design will not, it will not generate the correct result for you in the simulation. So you have to analyze whether the signal generated at at the design level is a problem or the signal generated at the test bench level is a problem. And you have to make necessary changes in that case. If the design is not working correctly, you have to make changes to your design file, design Verilog file, which is this. If the test bench is not being applied or the test signals in the test bench is not applied correctly, then you have to make changes to the test bench file and then do the whole process again. Relaunch your simulation, recompile it, relaunch the simulation and check the timing diagram again. Okay.
Okay.
Any questions on in this part?
No. No.
No? Okay. So if you want, I can maybe show you another demo. So I have an encoder design. Okay, so it's a 8:3 encoder. What is module encode 8_3 input I, which is a 8-bit input, then output Y, which is a 3-bit output. So I'm declaring a reg. So reg can be declared here also. So instead of declaring it here on a separate line, I can declare the reg here itself. Output reg 2 down to 0 Y. So Y is the output 3 bits and Y is also reg 3 bits. Same name. Then always, this is the always block here. Always at I is my input. So this is the sensitivity list. Begin the always block. Under the always block, I have a case statement where the case variable is I. And when I is 0000001, first bit, 0th bit is high, output will be 000. When I is 10, which is first bit, this was 0th bit high, this is first bit I, output will be 001. If second bit is high in the input, output will be 010. Third bit is high, then 011. So all the way up to 7 bit. If 7 bit is high, output will be 111. In case of for case statement, there should be a default. So if it is not one of these combinations, only one input can be high at a time. You cannot have more than one input high. So if there is any other combination of input, it should display in the simulation window. Dollar display will display error in the simulation window. End the case statement, end always block, end module. This is my encoder. Now I want to write a test bench for the encoder. This is my test bench. Pick time scale, which is the first thing you do in a test bench is declare a time scale. 1 nanosecond, 1 nanosecond. So default time scale is in increments of 1 nanosecond. I can zoom up to 1 nanosecond level. Okay. Module encode 8 underscore 3 test, which has empty input output ports. So there is no input output ports declared for the module test bench because that's how it works. Now we are going to instantiate the design. For inputs, I need to declare a register. For outputs, I need to declare a wire. So I declare those two and do the port mapping after doing the instantiations. So I can say UUT or you can call it anything you want. So typically you call DUT or UUT. DUT stands for design under test. UUT stands for unit under test. Or you can give it some other name. I can say inst underscore encode, which is an encoder instance. Inst underscore encoder. So I can call it anything I want. Initial. So I need to change the inputs now. I've done the instance and the port mapping. Initial begin the initial block. I is initially 0. After 10, so hash 10 into 1 nanosecond. So after 10 nanosecond, I will be MSB bit is 1. After another 10 nanosecond, the 6th bit is 1. Rest of the bits input bits are 0. So after every 10 nanoseconds, I push it on the right hand side. 7th bit is 1, then 6th bit is 1, then 5th, 4th, 3rd, 2nd, 1, and then 1. And after another 10, maybe I can show this I is equal to, I'm making 3 bits 1, 0, 1, and 2. This should not be accepted. So let's see. And the initial block, and I can have another initial block where I can put a dollar monitor there. Dollar monitor is a system task which will monitor the inputs and outputs or the signals given. So in this case, I'm monitoring the input of the design and the output of the design. The way dollar monitor is, anytime I changes or any Y or I changes, it will show you new message in the simulation window. Only when the values change. But it will run parallelly, so it will keep monitoring the signal. So in this case, I is input and Y will be output coming back from the design. So it will monitor both the signals. Anytime any signal changes, the new message will be displayed in the simulation window. End initial block, end module. So this is my test bench. So any questions on the design or the test bench for encoder?
No.
Okay, so if I let's create another project. So I need to close this project, so which is open right now. So file, close project. Then I will go to new project and I will use the file, the directory location where my Verilog source code is. I will call it project underscore encoder 2 because I probably have another project declared somewhere. So rest of the things can be same. You can select some one of the devices. Default language should be Verilog. I say okay. So project is created now. I need to add the source code. So project add source. This is my implementation directory. So I go one level above. I select the two files, which is my design file and the test bench file here. Say open. Test bench file by default it has come association all. So I should change that. For test bench, association should be simulation only. For design, it should be simulation and implementation. So all. I say okay. This is implementation tab. I go to simulation tab here. This is my test bench of the encoder, under which if I expand this, it will be my design instance. I'm calling it inst encoder. That's the name of the instance or the label of the instance. So that's okay. I select test bench, expand this simulator and say simulate behavioral model. These are my test bench related signals. I right click them, name, long. So by default, if you see this, this is where all the changes are happening. So I can make those. So what I can do here is, now by default it will show you in hexadecimal format. If you want to display this in binary format, you can select this signal, input I of the test bench, right click it, radix binary. By default it is hexadecimal. If I select binary, it will show in binary format. Do you see this? Yeah.
Yeah.
So initially, let's see what is happening now. Let's see whether my simulation is correct. Initially, everything was zero. My input was zero. Output is X, unknown. We'll see what that means. Then input changed to 100. 7 bit is 1. So since 7 bit is 1, now let me change the output also to binary format. Radix binary. So when 7 bit was high, output is 111. And 6 bit is high of the input is output is 110. Then fifth bit is high 101. Whole bit is high 100. Third bit is high 011. Second bit is high 010. First bit is high 001. Then when zeroth bit is high 000. And it stayed there because there is no other. Then later on input became 011. So all three are 1, which is where if you see your bottom displayed, the various values are displayed. And you will see an error here. Okay. So this thing that you see here in the bottom window is due to the dollar monitor system task. So it will keep showing you y and I values. Now this is shown in decimal format. You can also change it to binary format if you wish. So initially I was 0, so y was x. Let me change it to binary. Let's rerun it once. So input, so percent %d for decimal, percent %b for binary. So let's put both in binary format. Input and output. I go here, I relaunch my simulation. I will not save any configuration here. So if you see here, I initially was 0, Y was XXX. Then I became 100, MSB 7 bit is high, Y became 111. Then 6 bit is high, Y became 110. Fifth bit is high, 101. Fourth bit is high, 100 output. Third bit high, 011. So on till 0. And zeroth bit was high, output was 000. Then later on input was 111. So output stayed 0 and it showed me error here because that's how my design is working. If you look at my design, any other input apart from this, it will display error. Okay. When initially my MSB 7th bit was high, output was 111. Then the 6th bit was high, output was 110, which is 6. And 5th bit was high, output was 101, which is 5. Then fourth bit was high, output was 100. So that's what my simulation timing diagram is showing here, right?
Yes.
So my simulation seems to be working okay. My design seems to be working okay. So I can say that my design is functionally is correct and is functionally verified. Okay, any questions?
No.
Okay. Um, so do you understand the design concept of Verilog design test bench and how to simulate that test bench using the simulator and how to generate a
Yeah.
timing diagram?
Yeah.
Okay. Um, any other questions related to any other topics?
No. No questions. That's
Okay. So you don't have access to your laptop right now, right? You cannot try out anything.
yeah.
Okay. So we will. I mean, that is all I had from my side. I normally keep this couple of classes for practice purpose. So whatever problems you face, I try to help you resolve those problems. That's typically how it works. So if you get access to your laptop, or if you can try it out, and if you have any questions, we can take them in the next class. Um, you can. I have already given you a few tasks, so you can try them out at your end. And this is how you do it. How you perform the simulation, creating projects, and adding the source code and running simulations. So if you have any
Okay.
questions in the next class, we can take them up.
Yeah, sure.
Okay.
So this is like next class would be the end of the training, right?
Yes, next class will be the end of the training. Yes.
Okay.
So today is 15th lecture. Next will be 16th lecture. 16th lecture is when we stop after 16th lecture.
Okay.
So, okay, um, I mean that's all I have. Do you have anything else that you would like to be clarified, or anything?
No, look, like I also got the recordings of the first six classes.
Okay.
Maybe they'll send out the recordings after later. So
Okay.
if I have any doubts, I always have the recordings to go through.
Right.
And yeah, so I will try to simulate things and let's see how things progress after this training because based on this, I should get into a job very soon.
Right.
Yeah,
Yes.
so
So yeah. So you keep practicing, because I think that's very important for you to practice. If you practice, you'll get more confidence. Based on this,
yeah,
that will help you in your interviews and any test that you might have to take as a part of that.
yeah,
So that's I think the practice is the best part, because without practice you won't really gain a lot of confidence in this thing.
yeah,
You need to practice this, and then let's see beyond that if you have anything else. Okay.
yeah, sure.
Okay, okay, Anil. Thank you. Yeah. So we'll
Thank
stop
you.
today here in this case. Okay.
Yeah,
Okay. 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 Let's. Next class will be on Monday. So in case you're going to join, we'll see if you have any questions. I'll be here on Monday. So if you have any
okay.
questions, we'll take them up. If not, we'll see how to progress on that. Okay.
Yeah, sure.